Hi everyone, this is Jagriff, and today I'm going to be discussing this teleporter hub that you see on the screen. This is a binary teleporter hub. I actually call it a binary tree teleporter hub because it sort of behaves like a binary tree. You go from the bottom and then you branch out with 2 branches, and then from each of those nodes, we'll say, you branch out from 2 more branches, and so forth. Anyway, we'll discuss how it works in a second, but first, let's just show you how to use it. And so it takes a binary input, and so that means we just turn several levers on or off. And then based on that input, we will teleport to different locations. So for instance, if we wanted to go to, let's see, if we wanted to go to my pumpkin patch here, which is located at X9, we would select X, and we would select 9 among the other 4. And so 9 we can obtain with 8 and 1. And so we would select 8, 1, and X. And this will send us to that pumpkin patch, which we have here on the right. And now back teleportation also works with this hub, so we hit that switch and we end up back where we started. Let's do a couple more examples. So let's see, we have my flower garden, which is on 1, so that means we deselect X, we deselect 8, we only leave 1 on, and then we go to the flower garden. And we see some fire blooms are in bloom. And let's go back. Let's see, we also have, let's see, my fallen star farm. So we can select, it's at X0, so we select X and we select 0 among the other bits, and that would send us to the fallen star farm. And here we are. Now of course there aren't any stars, it's not night yet, it's about to be night. And so that's how they use it. So essentially with only 5 levers, we can control up to 2 to the 5 outputs. So 32 different destination teleporters are allowed with this setup. This actually technique can be expanded to any power of 2 very easily. So if you want to have it less, you want to have 16, or you can even go up to 64 or 128 if you're really insane. And so as you can see, these destination teleporters are wired with the red wires mostly, although I also use green and yellow for some of the other ones. So right now I don't even have 32 hooked up. It looks like I only have 16 plus 4 more, so 20 teleporters are hooked up. So let's go ahead and go into my little test room that I built, which is at 15, so 8, 4, 2, and 1, to see how this whole thing works. So let's come up here. And so I'm going to go through several stages, and each stage will show us a new component of this teleporter hub. So at stage 1, we're going to look at the very basic building blocks, which are logic gates. And actually we're looking at very simple logic gates. So for the first part, we have just any logic gate. And so here I have an AND gate, but any logic gate will behave the exact same way because we only have 1 lamp above it. And now hooked up to that lamp is a lever, and so that will turn the lamp on and off. So the lamp's going on and off. And now hooked up to the gate is a torch, just to display output. And so what happens is whenever the lever turns on and off, it turns this lamp on or off. So the state of the lamp changes. And whenever you have a logic gate, any logic gate with 1 lamp above it, and that lamp changes state, the gate will change state. And when the gate changes state, it'll send a pulse. In this case, it'll send a pulse to this torch, turning it on or off. And so this is a very complicated way, actually, of controlling a torch with a lever. But this extra little complication of the logic gate will allow us to do some cool things. You can use this to change wire color, although we're not going to use that in this build. But in this build, actually, we're using a delayed mechanism. And so instead of hooking up this torch to this lever directly, we're going to have a short delay. Whenever we pull the lever, the torch doesn't turn on immediately first. This lamp turns on. Then this gate turns on or off. And then the torch turns on or off. And so this delay is going to allow us to teleport several times in 1 click. And now the second building block is again any logic gate with an on or off lamp above it, and then above that is a faulty logic gate lamp. And now what faulty logic gate lamps do is they introduce a randomization in Terraria. If you have, say you had 6 lamps below the faulty logic gate lamp, and 2 of those lamps were on, then whenever that faulty lamp received a pulse, since you have 2 lamps on out of 6 total, there would be a 1/3 chance that the gate sends a signal. Now, we don't want to have any probability in this build, we want it to be completely deterministic. So, we only have 1 lamp below it. And so now, if that lamp is off, any pulse to that faulty lamp will do nothing. And so this lever is going to do nothing because the lamp below it is off. If the switch is on, or sorry, if the switch turns the lamp on, then the lever will send a pulse to the faulty lamp. But now that that lamp is on, the faulty lamp will cause the logic gate to change state, or in this case actually send a signal. There are no states in a faulty logic gate lamp. So now the lever will cause this gate to send a signal, causing this torch to turn on and off. So let's see that. And so now this is a simple way to build something. Like, say you want people to only be able to turn the lights on if a certain switch is turned on. And then we can't turn the lights on and off. But now we can. Now this would be very useful in this build. This is going to sort of control which path we take. Before we get into that, let's start off with some basic teleporting. So in stage 2 we have 2 columns of 3 teleporters. And now the first column has just the first teleporter wired with a lever, and that wire is also connecting the second and third teleporter together. So now what happens when you pull the lever? The game, whenever you pull a lever, the game searches by wire length to find the first teleporter, and so that would be the bottom one. And then it searches by wire to find the furthest teleporter, which in this case would be the top one. And then it causes a teleportation to occur between those two. So actually, in this setup, we're going to teleport from the bottom to the top and completely bypassing the middle. There's really no reason to have this teleporter here. It's not doing anything. And so there you go. I teleport from the bottom to the top. And you didn't see particles in the middle. So let's do that again. So in the middle, you're not going to see any particles because nothing happened in the middle. I went straight from the bottom to the top. That differs if we use this delayed mechanism. So again, you're using this this simple logic gate we saw in stage 1. Again, this is any logic gate with any lamp above it, any on or off lamp. And what are we doing? So we hook up this lever through blue wire to the 2 teleporters. And so when we pull this lever, we're going to teleport to the middle teleporter. At the same time, this wire is going to turn this lamp on or off. So in this case, off. It's going to change the state of this lamp. That's what is important, changing the state, not turning it on or off. So we change the state of this lamp, and then that's going to change the state of the gate. And changing the state of the gate is going to cause it to send a pulse. And so it does that through the green wire, and that connects the second and third teleporters. So this one pull of the lever is going to cause us to teleport to the second teleporter, and then in turn cause us to teleport to the third teleporter because of this logic gate. And so let's see that. In this case, I'm going to have the same result from 2. I'm going to end up at the top, but you're going to see particles in the middle because I actually arrived at the middle teleporter on my way to the top. Now this will also be useful later on. Actually, we're going to combine this with what we're about to see to create the hub. There's really no reason to stop in the middle teleporter for a brief millisecond actually, for this system, but maybe here we had something more complicated. Maybe we had a decision instead of just a simple delayed mechanism. If we made a decision on which way to go, then that may be useful. You'll see what I mean here in a second. So let's go to stage 3. So here we have 3 teleporters, one on the bottom, and then one to the left above it, and one to the right above it. And each teleporter at the top has a faulty logic gate system hooked up to it. So that is any logic gate with an on or off lamp with a faulty logic gate lamp above it. And now here, the state does matter in the middle one, so we want to make sure one of them is off while the other one is on, and we have them both hooked up to this lever through the blue wire. And so that means this lever will change the state of both of the lamps at the same time. So this is sort of a toggle mechanism. And so this is what's making a choice. So if I select the lever like this, then this lamp is on. And so what's going to happen when I pull this lever, I'm going to teleport to the left teleporter. If I were to select the lamp on the right, I will now teleport up and to the right. So let's see how that works. First we have this lever hooked up with a blue wire to cause a toggling. And then we have the main lever, the lever that starts the teleport, hooked up with a yellow wire to each of the faulty logic gate lamps. And so now we've guaranteed that one of these lamps is on and one of them is off. So whenever this lever sends a pulse to the faulty logic gate lamp, only one of those logic gates is going to activate, and exactly one of those logic gates is going to activate. And so in this case, whenever I pull this lever, the yellow wire is going to send a pulse to this faulty logic gate lamp, which is going to do nothing because this lamp is off. It's also going to send a pulse to this logic gate lamp on the right, which is going to do something because this lamp is on. So let's check and see what it's going to do. This gate is connected to our original teleporter, and it's connected to our destination teleporter. So when I pull this lever, it's going to activate this faulty lamp, which in turn will activate this gate, which in turn will cause us to teleport up and to the right. And similarly, if we select the left path, this lever will activate this faulty lamp, and since this lamp below it is on, that will in turn cause this gate to send a pulse up and to the left. And so in stage 3 we have a branching mechanism. This is the one way to make a choice between left or right. That's all we're doing here, making a choice between left or right. In stage 2, we showed how you can go from one level to a next level to a next level at the same time, essentially. And so now actually we can combine 2 and 3. We will have the teleporter hub that I built. That's all it is these two combined. So let's show a basic example of these two being combined. So we're going to have 2 levels, like we did in stage 2, and at each level we're going to have a branching mechanism like we did in stage 3. And we reach a 2-bit teleportation hub. So this is a 2-bit hub, so we have 2 to the 2, or 4 destination teleporters, which I have over here. So that's 0, this is 1, this is 2, and this is teleporter 3. So with neither lever selected, I will teleport up to the 0 teleporter. And then in this case I also implemented back teleportation. So let me go ahead and go back. We could also go to 1, or we can go to 2, and finally we can go to teleporter 3. The only thing new here actually is the back teleportation, but let me discuss that last. First I will go and sort of review how we combine 2 and 3. So let's look at what happens first. Let's look at these levers. So this 2 lever is going to toggle the first level of teleporters. So it's actually going to toggle these lamps, just like the lever in stage 3 did. It toggled these lamps. In this case, this lever will toggle the first level of lamps. And now the second level of lamps are controlled by the 1 lever, and it's toggling those. And then our main lever, the one that causes all the teleportation to happen, is going to send a pulse to all of the faulty logic gate lamps. So first on the first level, and then on the second level. And so let me show you the wiring. So you see this lever is hooked up to the torches that turn the torches on, but also to these lamps. And then the first lever, or the lever 1, is going to be hooked up to the second level of lamps. And of course it also touches the torches so that we have a visual display of what we're inputting. And this main lever with the yellow wire is touching all of the faulty logic gate lamps. And now here wire length does matter. We want to make sure that we teleport to the first level first, and then we teleport to the second level. So it's important that the wire connecting this lever and the bottom row of faulty logic gate lamps is shorter than the wire that connects the lever and the top row of faulty logic gate lamps. I will show you how I did this in the big hub once we get there, but for now it's fairly obvious to see that this bottom row has a shorter wire length than the top row. And that's the teleportation. So let me go ahead and select something. Let me select 1. So this should send us to teleporter 1. And we can even see the display of that on the lamps as well. Since we have these 2 lamps and only one of them is on, so this one's on. So when we pull this lever, it's going to send a pulse to this faulty lamp, which is going to activate this AND gate. And of course, this is not necessarily an AND gate, it could be any gate, because once you put a faulty logic lamp above a gate, it becomes a faulty gate, essentially. So any logic gate will work here. Anyway, once we pull this lever, we activate this faulty lamp, which will activate this gate because the lamp below it is on. And whenever this gate is activated, it connects with green wire, this teleporter, which is our original teleporter, with the teleporter right there on the left. At the same time, or not at the same time, actually directly after, this yellow wire also touches the top row of faulty lamps. It first touches this faulty lamp over here, and so that's going to cause this gate to send a signal, which will cause a teleportation to occur between this teleporter and the teleporter over here. Now, if I were to pull the lever now, you won't even see this happening because I'm not going to anywhere touch either of these teleporters. Because I'm going to first teleport to this teleporter here on the left. And so this activation, oh my gosh, this activation will not really do anything. What's important though is this activation. Whenever this yellow wire touches the faulty lamp here, that's going to activate this gate here, which will cause a teleportation to occur between this teleporter and this teleporter. Which is important because I'm already going to be at this teleporter when that happens. So this will actually teleport me up to the left and then up to the right. And you can even see the particles. I arrived at this teleporter for a very brief moment. And so this is all there is to the teleporter hub. So this is actually how we combine 2 and 3. And so there is one more thing that I should discuss, and that is the back teleportation. And so how am I able to hit this lever and then end up back at the beginning? And so that's done by this other blue wire. So pay attention, there is a junction box here. I have a blue wire connecting my original teleporter with all of the teleporters on the last row before my destination. Now in this case I only have 2 levels, so it's connecting the original teleporter with all the teleporters on the first level. But if I had 10 levels, this would have to connect the teleporter on my original teleporter with all the teleporters on the 9th level. You'll see an example of that once we get to the main hub. Anyway, with this blue wire, we connect these teleporters, and we also connect with these simple logic gates. Now these aren't faulty. This is the first case actually we saw. It's a logic gate, any logic gate, with an on or off lamp above it. And now whenever we teleport, so let me go ahead and go to 2. That's this teleporter over here. This green wire, once we're on this stage, will teleport us up to our destination teleporter. Now it's important that this green wire also touches this lamp above that logic gate. Because what that'll allow us to do is now when we hit this lever here with the green wire, that will go and it will change the state of this lamp, which will change the state of this gate, which will cause it to send a pulse. And so whenever this gate sends a pulse, it's going to connect the nearest teleporter, which is this one, with the furthest teleporter, which is this one. And so when we pull this lever, first we're going to teleport to this teleporter through the green wire, and then we're going to begin we're going to use a delay mechanism to teleport us from this teleporter to the bottom. And the delay mechanism is using this simple logic gate with any lamp above it. And so you'll see the particles whenever I hit this lever. I'm going to teleport first to here and then to our original teleporter. And so we do that for each teleporter, and now we have a way to back teleport. And I want to point out that this back teleportation does not depend at all on the state of the system. So we're not checking these lamps at all. What that means is that we can back teleport from this teleporter while the system is in the current state, But we can also back teleport from the other teleporters as well. It does not depend on the state of the system. And so this is useful if you are out exploring and you went somewhere but then you want to come back from somewhere else, and you can still do that. And so that's all there is to it. This is the basic teleporter hub, and what we're going to do is actually multiply this for several more bits. So right now we have 2 levels. One level here, and then our second level is actually our destination teleporters. We just need to multiply this several more times. And so in the final teleporter that I'm going to demonstrate, we have 5 levels, which is controlled by 5 bits, which gives us 2 to the 5th, or 32 destination teleporters. And so you see at each stage, you really just have a duplication of that branching mechanism. At any teleporter you look at, you see the 2 above it that it will branch to. And so I'm just circling a few now, so you can get the idea. Now you also have a delayed mechanism. So this lever, so before I actually show you the wiring here, let me point out that this teleporter that I'm standing on right now, and these 2 switches, which are connected with blue wire, are not part of the hub. And this player sensor is not part of the hub either. It's just for a little nicety that I have set up. And then this other bell and whistle I have set up is over here. This other player sensor, in case I ever get stuck in the hub, I can get out very easily. So please ignore the wiring, this green wire here, this blue wire going this way, and this yellow wire here. This is not part of the hub. What is part of the hub is this teleporter I have right here, painted in shadow paint, which is connected to by these green wires, and also this blue wire. And also, we have the yellow wire here, which is connected to a lever, which is also painted with shadow paint. And so now the same thing happens, except it happens at several levels. So whenever I have a certain state hooked up, let me go ahead and hook up something like this. We have 5, which will send me to my truffle worm farm. Actually, this is a copy of Joe Price's truffle worm farm. What happens when I select 5 and I hit this lever through the yellow wire will send a pulse to all of the rows of the faulty logic gate lamps. And now I was very careful to make sure that it sends the pulse to the bottom rows first. So I had to actually extend the wire a little bit so that this faulty lamp will get hit before this one. And again, I had to extend this wire so that this lamp will get hit before this one, because we want to make sure that we are at the teleporter before teleportation occurs at the next level. And so anyway, whenever we pull this yellow wire, it's going to activate all of these lamps, activating this one first. And since this lamp below it is on, we will teleport first to this teleporter, and then we look up above this teleporter to see 2 more, and this one's on, so we'll teleport to this one, and then we'll teleport to this one, and then we'll teleport to this one, and then we will teleport to whatever this gate is hooked up to, because this lamp is on, and so that's hooked up with red wire. This red wire goes over here to the left, and it goes very far away to this truffle worm farm that I have set up. And I'll even show you that. It's a copy of Joe Price's truffle worm farm. I would encourage everyone to check out his videos on YouTube, Joe Price. I will give a link to his channel in the description. If you're interested in wiring, he has a lot of really awesome builds. And so that's how it works. I do want to point out also that the wire length for the blue wire is important. And so here you can see I actually made it a little longer than it needed to be, just so that the back teleportation will work. So let me show you an example of it not working. So let me make this wire a little shorter. And so now what happens, if we teleport to our final teleporter, which is at X15, it's our very last teleporter. So that'll send us to this teleporter and then eventually to the one that's hooked up on the right. And now whenever we back teleport, we're going to back teleport first from that teleporter to this one. And now once we end up at this one, remember we have a delayed mechanism with this logic gate and the lamp above it, which will teleport us through the blue wire. Now, since I shortened the length of this wire, we will actually teleport from this teleporter to the one way over here to the left. Because remember, teleportation occurs between the shortest length teleporter and the longest length teleporter, which would be this one and this one. And so let me show you an example of the system breaking when I do not have this wire extended. So let me go to X15, and I just have a teleporter right here hooked up. And if I teleport back, I'll end up to the far left teleporter on the top row. And you can even see particles. Oh, I was too slow. Let me come back down and do it one more time. You will see particles here because first I teleported to this teleporter and then to this one. So first you see particles me going up and then over here, and now you'll see particles. Get there fast enough, you can see particles, meaning that I teleported from this outside teleporter way over here to this one, and then over here to this one. And so in order for the system to work, I need to make sure that the wire length is always longest going to my original teleporter. So I do that by adding these little divots here, and now it should work properly. So let's see. And so when I did back teleportation, I teleported from that teleporter over there to this one, and then from this one to my original teleporter. And that's all there is to it. So in the description, I'll have a link to these pictures, which is actually going to be a Reddit thread, but it has these pictures on it. And so you can see how everything is hooked up. I think most of you will be able to understand it fairly easily after giving it some time of reviewing this video in the previous stages. Stage 1 through 4 were very important in understanding this big thing. This big thing is really just a multiplication of the 4th stage, adding more levels. And that's all there is to it. So if you have any questions, please let me know. I'll do my best to answer them. And if you want to see any other Terraria videos, any wire-related stuff, please let me know. I'll do my best to provide those for you. Thank you for watching.